We are going to get started. I just want to thank you all for joining us for our webinar today. Just a couple housekeeping items before I introduce our presenter and get her started. Your mics, if you have not noticed, are muted, and they will remain muted throughout the presentation. We ask that if at all possible, you save your questions to the end of the presentation. We will have a question period of about 15 minutes where you can raise your hand, and I will unmute your mic and you can ask the questions. However, if you do have a burning question in the middle of the presentation, if you send that to me via the chat function in WebEx, I can moderate those questions throughout. We can expect about a 45-minute presentation from Fiza today, and then as discussed, there will be about 15 minutes for questions at the end. And Fiza has agreed to allow us to pass along her contact information, so if you wake up tomorrow morning with more questions about the nuances of reward system and problem gambling, we can make sure you have Fiza's information to ask those questions. There will be a very brief evaluation following Fiza's presentation, and if you wouldn't mind completing that evaluation, we would really value your feedback. As well, we will be recording this webinar in full. So if you missed pieces of it or if you'd like to refer back, we should have that up before the holidays for you to refer back to. And so now I'm going to introduce our presenter to you. Fiza Arshad is a second-year MSc candidate in the Neuroscience Graduate Program at McMaster University. She is training at the Peter Boris Center for Addictions Research under the supervision of Dr. Iris Olotis. Her research interests include exploring the neurobiological and physiological basis of stress and behavioral inhibition in problem gambling. And today, Fiza is going to be presenting information included in a white paper she wrote for us here at GRIO, and her presentation is titled Nuances of the Reward System in Problem Gambling. So I'm going to pass it over to Fiza.
All right, thank you for the introduction, Lindsay. Can you hear me okay?
Yeah.
Okay, great. So my presentation, as Lindsay said, is titled Nuances of the Reward System in Problem Gambling. So the guiding question here is, how does the reward system impact gambling behavior? And this question can then be divided into two components. A, what really is the brain's reward system? Two, and what is gambling behavior? Although this presentation will predominantly focus on the reward system, I hope some of it perhaps shines some light on gambling behavior as well, as there are different ways to measure gambling behavior in the lab depending on your approach. So what are our objectives for today? Well, I'll start off with an introduction. Followed by the introduction, I will head straight into talking about the rewards and reward system, and then some methods that are important for our discussion on the history of addictions research, which includes stages of reward processing, reward system activity, dopamine's role in the reward system, as well as then the current status of the science of gambling, which hopefully shed some light on the limitations and future directions. But wait, I will also talk about what the research like here in Canada on the reward system. So, right, moving on. So what really is gambling? Gambling in the Oxford Dictionary is defined as to play games of chance for money, meaning to bet, or to take a risky action in the hope of a desired result. So here, some keywords are action and outcome. So this action-outcome contingency is evident even in the dictionary right off the bat. This will become more relevant later on. So again, our action would be to gamble, and the desired outcome could be, say, to earn some money. And at the bottom, you'll see some gambling stimuli, cues. So depending on, there are a variety of gambling cues. They could be poker chips, dice, slot machines, or cards. And here, I think it'd be good to mention that there is a lot of diversity in gambling type preferences. So, for example, from my experience, I've noticed that participants who like to play slot machines don't usually like more strategic games like poker or blackjack. On the other hand, those who like strategic games definitely do not like slot machines as much, which is more non-strategic and automatic. So why is gambling a problem? I thought it'd be nice to start off with the DSM-V criteria of opioid use disorder, so as to then better understand that of gambling disorder. So opioid use disorder, briefly, it's a substance-related disorder, obviously, and it's defined as, taking the opioid in larger amounts and for longer than intended. And if you read down the slide, it includes things like wanting to cut down or quit but not being able to, and craving opioids, continuing to use it despite negative consequences on social, occupational, and recreational facets of an individual's life. It also includes tolerance and withdrawal. Moving on, this maps nicely onto the DSM-V criteria of the gambling disorder, and I'll read over this in a lot more detail. So gambling disorder has just been added under the substance-related category in the DSM-V in 2013, so it's been a very recent addition. It's defined as persistent and recurrent problematic gambling behavior that leads to clinically significant impairment or distress, as indicated by the individual experiencing 4 or more of the following within a 12-month period. So again, it includes things like tolerance, meaning needing to gamble increasing amounts of money to achieve the same desired excitement, feeling irritable or restless when attempting to cut down gambling, of being preoccupied with gambling, feeling distressed, which could lead to gambling, as well as lying to conceal the extent of involvement with gambling, as well as negative consequences on an individual's life, their relationship, job, education, or career, as well as financial consequences on someone's finances. So one thing I'd like to point out in particular is chasing losses, that this criteria is unique to gambling disorder and not cannot be matched up with something similar in opioid use disorder or other related substance use disorders. And gambling, the diagnosis of a gambling disorder is warranted, but the exclusion criteria should be not that this behavior cannot be better explained by manic episodes. So again, there's, as you can see on the slide here, it could be episodic or persistent. If this disorder is not current, so within the past month, it could be, the patient could be in early remission or sustained remission. And then the DSM-V further divides it by the severity. It could be mild, moderate, or severe, depending on the number of criteria met. Moving on, so not all problematic gambling behavior warrants a diagnosis of a gambling disorder. Problematic gambling behavior can be problem gambling, so that's a more subclinical form of problematic gambling behavior where an individual exhibits perhaps 2 or 3 symptoms and they may not be as severe. So on your right, you see a cool bar, which is similar to a heat bar, but only cooler as it's blue. So the lighter blue indicates less severe symptoms. As you move down the bar, which can be likened to perhaps passing time as the individual continues to gamble, the color is now a darker blue, which reflects more severe problem gambling symptoms as well as a higher number of symptoms. And this clinical problematic gambling behavior used to be called pathological gambling in the DSM-IV. And I'm just pointing this out because most of the research that I'll discuss today does use the criteria that falls under DSM-IV, because the change to gambling disorder is very much recent. So just to keep that in mind, if you see pathological gambling on the slide, it refers to gambling disorder. So moving on to the meat of the presentation, how are the rewards and the reward system involved here? Right, so I thought it would be nice to start off with a brief introduction on one of the earlier papers by Olds and Miller. So addiction research starts off with Olds and Miller finding that electrical stimulation in certain areas of the brain is rewarding in a rat's brain. On your right is a graph that plots the number of bar presses, and you can see it's a steep linear increase with time. And further down the road, other people, as reviewed by Weiss, find that self-administration of drugs is related to dopamine release. So therefore, we can the conclusion here is that certain areas in the brain are rewarding, and dopamine is a neurotransmitter released by these brain regions that could be involved in this rewarding behavior. So what exactly does that mean, really? So in opioid use disorder, or really any substance use disorder, the reward is definitely the drug, so it could be in different forms, such as pills. In gambling disorder and problem gambling, the reward could be a dice, some cards, or slot machines, as I mentioned earlier. So how exactly is the reward system then involved? Well, the reward system regulates basically some brain regions working together to regulate an individual's reactions towards or away from rewards. So these are the brain regions, as you can see in the figure below. As you can see on the figure below, it's a very simplistic diagram, and these brain regions are also involved in other functions such as decision-making, learning, affect, and in the case of insula, in your gut feeling. And it really reflects the complexity of the reward system as well as of the brain regions involved in regulating someone's reactions towards or away from rewards. So just to keep that in mind as we carry on with our discussion here. So I thought it'd be nice to kind of view this video. It does slightly more better job at explaining this. Let me know if you cannot hear, and I'll do something about it.
Welcome to 2-Minute Neuroscience, where I simplistically explain neuroscience topics in 2 minutes or less. In this installment, I will discuss the reward system. The reward system refers to a group of structures that are activated whenever we experience something rewarding, like using an addictive drug. When exposed to a rewarding stimulus, the brain responds by increasing release of the neurotransmitter dopamine. Thus, structures that are considered part of the reward system are found along the major dopamine pathways in the brain. The pathway most often associated with reward is the mesolimbic dopamine pathway, which starts in an area of the brainstem called the ventral tegmental area, or VTA. The VTA is one of the principal dopamine-producing areas in the brain, and the mesolimbic dopamine pathway connects it with the nucleus accumbens, a nucleus found in a part of the brain that is strongly associated with motivation and reward, called the ventral striatum. When we use an addictive drug or experience something rewarding, dopamine neurons in the VTA are activated. These neurons project to the nucleus accumbens via the mesolimbic dopamine pathway, and their activation causes dopamine levels in the nucleus accumbens to rise. Another major dopamine pathway, the mesocortical pathway, also originates in the VTA, but travels to the cerebral cortex, specifically to the frontal lobes. It is also activated during rewarding experiences and is considered part of the reward system. Because dopamine is released whenever we use an addictive drug, researchers initially thought dopamine must be the neurotransmitter that causes pleasure. More recent research, however, suggests that dopamine activity doesn't correlate exactly with pleasure. For example, dopamine neurons are activated before a reward is actually received, and thus before the pleasure is experienced. For this and other reasons, it is now thought that dopamine has roles other than causing pleasure, such as assigning importance to environmental stimuli associated with rewards and increasing reward seeking. Whatever the precise role of dopamine in reward is, the mesolimbic dopamine pathway is consistently activated during rewarding experiences, leading it to be considered the main structure of the reward system. Regardless, the actual network of brain structures involved in mediating reward is much larger and more complex than just this dopamine pathway, involving many other brain regions and neurotransmitters.
All right, so as we saw in the video, the reward system involves multiple pathways, two of which are the MESOLIMBIC dopamine pathway as well as the mesocortical dopamine pathway. So here this diagram presents a more schematic view of what the video just covered. And again, these brain regions are not, they don't represent the exact spatial location of what it looks like in this case in the brain. I think this is the rat's brain. So basically, the dopaminergic projections originate not just from the ventral segmental area, so the VDA, but also the substantia nigra, the SN. They could project to the nucleus accumbens. And some projections also go on to the medial frontal cortex. In addition to this, there are other pathways involved in this reward system. There are projections from the medial prefrontal cortex, for example, to the striatum. And just to give you an idea of the multiple pathways involved in the system as a whole. In addition to that, at the bottom of this figure, you can see that there are different neurotransmitters that are involved. So it's not just dopamine, but there is dopamine, glutamate, acetylcholine, as well as GABA. Relevant here in this presentation is dopamine, as it is the, historically it has been up till now the most studied neurotransmitter with regards to rewards in the reward system. And yeah, so basically we focus on dopamine a lot more than the others. Not to say that they're not relevant, but they're not as well studied with regards to the reward system and its role. So moving on here, again, I have listed some brain regions that are involved in the reward system, and these include the ventral striatum, the nucleus accumbens, the ventral medial prefrontal cortex, as well as the anterior cingulate cortex. And these are some of the brain regions that I'll be talking about further in some of the discussions in this presentation. To note is the nucleus accumbens, as you just saw previously, it receives dopaminergic projections from the VDA, so the ventral segmental area, as well as the substantia nigra. It's a section of the ventral striatum, so the ventral striatum includes nucleus accumbens. And yeah, moving on. So the question now is, how is the reward system that includes all of these brain regions as well as neurotransmitters involved in addiction? There are three main hypotheses that speak to this question. We have the reward deficiency syndrome, the impulsivity theory, as well as the incentive salience hypothesis. So moving on to the reward deficiency syndrome. So the basic idea is that there is a hyperactive reward system, which leads to an individual wanting to seek external rewards. So as you can see in the diagram below, here there's a hyperactive reward system that leads to the person seeking external reward, and then this becomes a pathological cycle that continues and defines addiction. And the impulsivity theory, on the other hand, is very recent, and here the basic assumption is that there is a hyperactive reward system, as reflected by this darker blue arrow pointing upwards, and that leads to an individual seeking rewards. So the reward again could be poker chips, cards, or whatever is the preference of the gambler. And then because that leads to reward and pleasure, the person continues to gamble, and that becomes a pathological cycle. The third hypothesis, on the other hand, is the incentive salience hypothesis, which is one of my favorites. I'm a little biased. So the idea, there are two main ideas. But first, it's important to know that there are no basic assumptions on the hypo or hyperactivity of the reward system. What this hypothesis proposes is that initially an individual likes to gamble, and as they continue to gamble with time, this gambling leads to an increased saliency towards gambling cues, meaning a person pays more attention to gambling cues as well as the environment that they're gambling in. So again, that includes sights, sounds, food if they're eating at that time, things like that. And at that phase is characterized by wanting. So again, I think this graph does a good job of kind of presenting that. So with time, during the problem gambling stage, people exhibit wanting to gamble, irrespective of whether they like to gamble or not. And again, at this point, most problem gamblers do identify that they cannot help but wanting to gamble despite the negative consequences that it may have in their lives. Moving on. So now I'll talk about some of the methods here that are relevant to my discussion. So some of the technical tools are, one of the most popular ones is functional magnetic resonance imaging, so fMRI, as well as EEG. We have PET scan as well, but for the purpose of this presentation, I'll be talking in more detail about these two only. So fMRI.
Fiza, I'm sorry to interrupt. Can you just make sure you're speaking into your phone microphone as much as possible?
Oh.
It's just a little bit fuzzy sometimes. Thank you.
No worries. Thanks for pointing it out. So fMRI basically it's a proxy that measures neural activity. So the idea is dependent on how much oxygen a brain region is receiving, and this bold response, blood oxygenation level dependent signal, is considered to be irrespective of neural activity. And again, some things to consider, it depends on the vasculature of the brain, so how much oxygen a certain region of the brain is receiving, which again depends on how close or far apart they may be from a blood vessel, for example. And it's a good measure because it still provides enough information about what brain regions may be active during a task, so it's a good indicator of function. And at the bottom you see sort of like an interesting read, and it's a blog article on what may be wrong with fMRI. I thought it was interesting. It's an interesting read, so I thought to share. Moving on to EEG. Well, EEG is a measure of electrical activity in the brain. It's based on which and how many neurons are active. So as you can see in this image, it basically includes, it could be an electrode cap, as you can see in this image here, or it could be just one or two electrodes placed at specific locations in the on your scalp. And this tool is dependent on how many neurons are active, because since it's not invasive, a large amount of neurons must be active in order for the electrodes to capture that, as you know, the skull kind of inhibits the signal traveling upwards. And this is what it looks like, the reading. So a good advantage of this tool is that it has good temporal resolution. So unlike fMRI, where we are limited by how fast or slow your hemodynamic response rate is, which is about 4 to 6 seconds, that basically is how fast the blood can be oxygenated or deoxygenated. That drives the neural response, the bold response. But in this case, the temporal resolution is good because we're not really concerned with it. However, one disadvantage is that it's bad at localization. So you're not able to tell what region may exactly be active. And another disadvantage is that it is only good at measuring cortical activity. So subcortical regions that are deeper in the brain are harder to study using this tool. So moving on, I'll talk about the history of addictions research. So in specific gambling addiction. So here, this is a seminal paper by Reuter and colleagues. It shows the different, what they did is they used a gambling task, and they found decreased activation in the ventral striatum and the ventral medial prefrontal cortex during a gambling task. So on your here, on your right, this is the ventral medial prefrontal cortex. It's in black and white, but it's basically this is showing decreased activation. And on your left, you will see the ventral striatum again, although it's in black and white, but this is where it is. So this region also shows decreased activation. And at the bottom, you'd see that in both cases, so decreased activation ventral striatum as well as the VMPFC, this decreased activity correlated with gambling severity. So higher scores correlated with a lot more decreased activation. And that's true for the VMPFC as well. But one thing to keep in mind is that this activation is relative. So this decreased activation in pathological, meaning those with a gambling disorder, it's relative to healthy controls. So it's not absolutely decreased activation, but relative, something to keep in mind. So what does that mean? Well, this kind of speaks to the reward deficiency syndrome, that there is a hypoactive reward system that leads to gamblers wanting to gamble. But some questions, this leads to further questions. For example, is this decreased activity because of reward outcome, or is it in anticipation of the reward? Therefore, this leads to the next phase. So apparently, the ventral striatum and VMPFC is differentially involved in outcome anticipation, which was found by Nuances and colleagues in another study. And what does it mean for gambling? Well, there are two distinct phases of reward processing, anticipation and outcome. And in both of these phases, there is decreased activity, again, relatively decreased activity in GD when compared to healthy controls in the ventral striatum, as well as the VMPFC, so that's the ventral medial prefrontal cortex. And here you can see the figure. So there are two phases, and the anticipation phase is further broken down by the A1 phase as well as the A2 phase. In the A1 phase, a participant is notified how much they may win in that trial. If it's a winning trial, it could also include loss of money. Followed by this is the A2 phase. So during the A2 phase is when a participant needs to press this button. Successfully pressing this button leads to a win or a loss, so that's the outcome phase. And why is this important? This is important because, for example, as Boloris and colleagues further found that ventral striatal activity during the A2 phase, it correlates with self-reported measures of impulsivity only when a participant wins, so during A2 win phase. So that's just some clinical relevance of why differentiating activity by phases is important. So just a little bit more on the task. They use the monetary incentive delay task, and again, this task is designed by Nuances and colleagues. This is also a 3x2 design. We can have, during the control task, we have a control queue, so that could be a chair, for example. Basically something which has no significance, rewarding or emotional significance. We could have a reward task or a punishment task. A reward task includes the reward. The punishment task includes a punishment cue here. And so day trials could be rewarded or not rewarded. And again, to note here is the action outcome contingency that I was talking about earlier. An action leads to a reward, so that the reward is contingent on correctly executing the action. And why is that important? Well, that's important because of dopamine. This action outcome contingency is apparently dependent, could be dependent on dopamine, some studies find. And this figure here again is just a reminder, which leads us nicely into our discussion of dopamine. Dopamine, as I said earlier, is a neurotransmitter involved in processing rewards. And dopamine is not only involved in substance use disorders, but also in gambling addiction. As you can see here in this figure, is study by Zach and Poulos. What they did is inject participants with a dopamine antagonist, haloperidol, and they find that it led to increase in self-report measures of enjoyment, excitement, and involvement, as well as an increased desire to gamble. So that's your figure on the right here. So therefore, basically it shows that dopamine leads to, it primes motivation to gamble as it increases the rewarding effects as well as desire to gamble. In this task here, Zach and Poulos used the, had participants play a slot machine game for about 15 minutes. Can you hear me? Hello? Hello? Oh, okay, great, thanks. So where was I? Right. So therefore, this study shows that dopamine is not only involved in substance use addiction, but it's also a primary neurotransmitter involved in feeling rewarded in gambling addiction as well. I'm so sorry, it keeps getting muffled. The phone's literally right next to my mouth. But thanks for letting me know. I'll try to speak a little bit slower, so hopefully that helps. If not, please do tell me.
All good, Fiza. Just keep doing your best.
Okay, thanks. So then this leads us to our next question. Where exactly is dopamine involved? Right? Is it in the ventral striatum or the VNPFC or any of the other brain regions that I listed earlier? Well, Linnet and colleagues have the answer to this. So here the participants were injected with a radioisotope, carbon-11 raclopride. So the idea is that this isotope binds to D2 or D3, so that's D2 or D3 dopaminergic receptors in the striatum. And of note is that decreased binding potential means that more dopamine could be available to bind to these receptors, and then the idea is that this is then imaged in a PET scan. So here they used an Iowa gambling task in a scanner, and as you can see here, that there is decreased binding potential in the ventral striatum of pathological gamblers during the game, the game trial of the gambling task, and increased binding potential during the loss trial of this gambling task. Of note is that during the game trial, this decrease wasn't statistically significant, but it was statistically significant in the loss trial. And this dopamine release is associated, therefore, is associated with losses in pathological gamblers in the ventral striatum. So which means that there is an increase in the release of dopamine in this brain region. And again, if you recall back that one of our hypotheses predicted a hyperactive reward system. So could it mean that increased dopamine release is parallel to a hyperactive reward system? That's an interesting question that researchers are still trying to find the answer to, because an increase or decrease release of dopamine may or may not mean a hyperactive reward system. Just something to keep in mind as we continue our discussion. So you may be wondering, what is the Iowa gambling task? Well, I have the answer. So here, the Iowa gambling task developed by Bechara and colleagues includes 4 decks, and deck A and B are disadvantageous, decks C and D are advantageous. The idea is that the participants get about, say, 20 minutes. It could be more or less depending on who's using the task, and there are different versions of it as well. But the basic idea is this, that during, say, deck A, the frequency of losing, so the frequency of losing money is higher, and during, and if someone chooses from deck B, the frequency of losing money is lower, so 10% of the trials lead to a loss of money. However, compared to deck A, deck B results in a higher loss of money. So as you can see here, it may lead to a loss of $12.50. However, overall, the net profit loss for both trials, for both decks, is $2.50. On the other hand, deck C and D are slightly similar in terms of frequency, but the loss is a lot less. So if a participant chooses deck C, they may lose less, but the frequency is higher. On the other hand, if someone chooses deck D, they may lose more, but the frequency is lower. However, in comparison to deck B, where the frequency is also 10%, the loss is still $2.50. So the loss is a lot less in comparison, the immediate loss. To balance out the net loss, the idea is that both advantageous and disadvantageous decks lead to a net profit loss of $2.50 in A and B, as well as a net gain of $2.50 in decks C and D. So it plays out pretty well. So moving on, what does this mean? So I talked about a hyperactive reward system and a hypoactive reward system. What exactly does this say about the reward system and its role in gambling addiction? Well, what we can say for sure is that gambling addiction is definitely defined by increased sensitivity towards gambling cues. So at the top here, you can this study done by Hewitt and colleagues show that when participants play blackjack, losing on a previous trial leads to increased probability of hitting on the following trial. So meaning losing leads to losing on a previous trial primes a gambler to continue to play further, and this plays out well in what we see in the real world, where first big loss may perhaps hook a gambler to gambling. And figures B and C again kind of show this in the brain, that there's increased activity in the anterior cingulate cortex. So this region is involved in emotional regulation and control in the reward system. Moving on, so at the bottom, this is proof for decreased sensitivity towards non-gambling cues. So for example, briefly, since we're running out of time, figure A shows that gamblers display a higher reaction time to erotic rewards in comparison to monetary rewards. So what exactly does an increased reaction time mean? Well, an increased reaction time means that the response rate is different and the sensitivity towards erotic rewards in comparison to monetary rewards is lower. So gamblers respond faster to monetary rewards, therefore they show a higher sensitivity to monetary rewards, and this plays off well with subjective ratings on these rewards. All right, so moving on. So what's the current status of the science of gambling? There are, in addition to these method diversity in methods, which lends to complexity of the research findings as well as of that the reward system, we also have different problem gambling subtypes. So there may be different pathways of the development of problem gambling as found by Blasinski and Nover. So we have those who are behaviorally conditioned to gambling. We have those who are emotionally vulnerable, as well as those who are antisocial and impulsive. So they find that, for example, those who are emotionally vulnerable report problem gambling, in addition to feeling, depressed or feeling endorsing negative symptoms. On the other hand, those, for example, who endorse the third pathway are more impulsive. More recent work shows that these pathways are not clearly defined. So as you can see on your right is a figure, and I encourage you, if you're interested, to read the paper by Valor. It basically shows that Group 2 endorses criteria 4 more often when compared to Group 1. So criteria 4 is basically, if you recall from DSM-4, criteria 4 is wanting to reduce gambling but not being able to. On the other hand, Group 3 endorsed criteria 9 more than when compared to Group 2. So criteria 9 is basically endangering personal or work relationships. And this group also endorses a high rate of suicidality when compared to Group 2. Moving on to Group 1, well, this, according to the findings by this group, they found Group 1 to perhaps lie in the middle and not have there may be a functional association here where perhaps it depends on their the individual's grading on impulsivity and neuroticism, for example. So other factors complicate the research further. Demographics such as age matter. So Savido and colleagues find that some subscales of the impulsivity scale, self-report scale of the UPPS is related to age. Further, the different brain regions are also show different connectivity. So for example, some find increased connectivity between the prefrontal cortex and the ventral striatum, and reduced connectivity between the different regions of the prefrontal cortex. And again, at the bottom is this, I've kind of copy-pasted this figure again as a reminder of the brain regions involved. So the medial prefrontal cortex and the dorsal anterior cingulate cortex, so that's the one in green. These regions are in the cortex, and in the striatum, we have the dorsal striatum that's responsible in habit formation, as well as the ventral striatum, which, as you know, is involved in reward processing, as we have discussed so far. So what does this show? This basically shows that the reward system may perhaps be dissociated from those regions in the cortex. Moving on briefly, I think I'm running out of time, but on this note, we have researchers at CAMH and UBC studying dopamine release as well as reward learning, plus the motivation underlying craving. Although there are other definitely many gambling labs in Canada that study problem gambling. In line with my narrative here, and as well as the research that I've discussed so far, I'll be focusing on some studies done by these groups. So dopamine and gambling severity. Well, as you can see here, this paper by Bello and colleagues shows that there is a decrease. Hold on. Right, so it shows that there is greater dopamine release in the dorsal striatum. And this is correlated with scores on the South Oak gambling screen, which is a screen for gambling severity. At the bottom, you'd see that this also correlates with impulsiveness, so ratings on the Einstein impulsivity scale. And that's another self-reported measure of impulsivity. So again, just a note, this difference in binding potential means that greater binding potential, decreased dopamine availability. Increased binding potential means decreased dopamine availability. So moving on, what does this mean for gambling severity? Well, another paper by this group finds that increased levels of dopamine in the substantia nigra, so that's the region that releases dopaminergic projections and sends it to the nucleus accumbens, as well as it's correlated with increased dopamine release in the striatum that predicts gambling severity. So something like this has important clinical implications that perhaps dopamine release, which is then again dependent on the method as well as the task used, may perhaps predict gambling severity, or the other way around. What does gambling severity say about dopamine release as well as the involved brain region? Okay, moving on. So I'll briefly talk about this cue reactivity study by Limbrick, Oldfield, and colleagues. So basic idea behind cue reactivity is that it measures reaction to cues. So again, it goes back to the idea of how an individual reacts towards or away from certain rewards. So here, as you can see, it defines increased activity. So the color red means increased activity in this brain region, the anterior cingulate cortex, that's responsible for emotional regulation in those with the gambling disorder. Again, this is relative. So this increased activity is seen in the brains of those with a gambling disorder when these participants see a gambling cue versus a non-gambling cue, but when compared to those with, when they see a gambling cue versus a neutral cue. And because this decrease is, even though it shows a decrease, overall it is analyzed as an increase because it's relative. Okay, moving on, this leads us to some limitations and future directions. So, so the main question then is, are these differences telling of the methods used, the Iowa gambling task versus the incentive delay task, or of the addictive brain? So it's important to tackle these gaps, look at differences within the reward system across the different paradigms, as well as how that differs by different gambling subtypes, as well as then looking at this activity within the reward system by gender identity as well as biological sex. But I thought it would be nice to end on a hopeful note. I think we are moving in that direction. So this important paper by Lujan et al. Shows that activity within gambling addiction differs from activity in the reward system that is seen in substance users. So briefly, hopefully we have some time for questions later, there is decreased activity relative to control in the ventral striatum here. in those with gambling addiction during both phases, so during the reward anticipation phase as well as the reward outcome phase. So this finding is similar to the reward deficiency hypothesis that I discussed earlier. However, on the other hand, as you can see here visually, that's not true of activity during reward outcome in substance users when compared to controls. Yeah, that's it. Do you all have any questions? And
so thank you very much to Fiza for that presentation. And she mentioned time for questions if you have any. So there is a function through WebEx where you can raise your hand and ask a question through your phone or computer, however you have called in. And if you don't have the ability to speak through a microphone or phone or whatever, if you want to send me a chat, I'm happy to ask a question on your behalf. Not seeing anything coming in right now. As I mentioned at the beginning of the presentation, we will be providing, Fiza, are you sharing your slides as well as your email address in the recording?
Sure.
Yeah. So we'll send an email out to everyone registered for this event, and it will include the link to the recording and the email address for sure, and then of course for slides, which is comfortable. It looks like we have a question from Candace. Go ahead, Candace.
I was just about to say that was a great presentation, Fiza. I really enjoyed it and learned a lot. Thank you.
Oh, thank you, Candace. That's nice of you.
And we have something in the Q&A as well. Oh, from Candace. Great presentation, Fiza. She said it both ways. Does anyone else have any questions? Okay, so we will allow you to just follow up with Fiza as things come up, as you're reading through the content and watching the recording. I just want to say thank you so much, Fiza, not only for writing the white paper to begin with, but then for also providing it for us today. It's always nice for us to be able to share this information through different venues, WebEx, papers, etc. So thank you so much for coming back and doing that again. It was a really wonderful presentation. As I mentioned, if you could please fill out an evaluation for the attendees on your way out, that would be really helpful. And thanks to everyone for joining us today. Thanks, Fiza.
Thanks. Bye.